Let's look in depth at this first example with the XJ35 batteries. So the first thing we can do is copy that data. So here is the life and days of those batteries. Then let's open a GeoGebra spreadsheet. So we'll go into View, we'll turn on Spreadsheet, turn off Graphics and Algebra. We'll then paste in that data. There's our 30 data points. We'll then select that column and do one variable analysis, a histogram, but what we're interested in are the statistics. And we can see that first number that was necessary, in fact, that caused us to be suspicious that the life is actually 500 days when we saw that the mean of our sample of 30 batteries was 490 days. Notice that we also have the standard deviation as if this was a population or a sample for these 30 batteries. We're not going to use that information. Remember, when we do hypothesis testing, we use the manufacturer's specifications. We were told that the average length of a life of a battery was 500 days with a standard deviation of 25 days. Remember, at the very start of this question, we were told that the manufacturer claims that the mean life of the battery is 500 days with a standard deviation of 25 days. So let's ask the question, how likely is it that battery lives in a sample of 30 would be at least that extreme as an average of 490 days? And so for that, we need the standard deviation of the sample means. That's sigma sub x bar. Remember, that's n, that's the population standard deviation sigma divided by the square root of n, and that gives us 4.56. So we now have enough information to actually calculate this area shown on the distribution of sample means, and we do that using a normal distribution. So let's go back to our resources for Chapter 6, where we've got our distributions, and let's look at the normal distribution calculator. So we're told that the mean of the samples was 500, and that the standard deviation of the sample means was 4.56. We just computed that. We want a probability. We want it to be at least as extreme as 490, and it looks like that means a left tail test, and that gives us our probability, 1.415 approximately percent. And that then tells us what our probability is. Notice that we can do this from inside of GeoGebra as well. So if I go back to the spreadsheet that we were using, this is the first one where we plugged in the life of the 30 batteries in our sample, and we got the mean of 490. Let's now look at a z-test of a mean. We're going to put in the manufacturer's specifications, so what we were told should be true about these batteries. That is a standard deviation of 25, and that the mean, the null hypothesis has a mean of 500, and that we were interested in showing that that was in fact lower. And here's our p-value, so exactly what we just got from the normal distribution calculator, about 1.42%. Here's our z-value, and of course reminding us of the mean of our sample of 30 things. That was that 490. So that gives us exactly the same information as well. Using the spreadsheet was useful because it calculated the mean for us. It allowed us to go into the statistics and then select the z-test of a mean, put in the manufacturer information, our alternative hypothesis, and of course use the mean from that sample. But if we'd known the mean, we could have gone straight into a calculator. So if we go back to the class resources for Chapter 7, and we look at the next application, notice here's a z-test of a mean, but not from a spreadsheet. This requires you to know what the sample's mean was. And here we're still putting in the manufacturer's claim for the standard deviation, and we're also putting in our sample size. So this allows us to compute that information, the z-score and the p-value directly from putting in data. But of course it has the drawback that we had to calculate the mean. So hopefully that ties those ideas together. You can use a spreadsheet to compute the mean. You can then use the normal probability distribution to find the probability of being at least that extreme. If you do that, be sure to use the standard deviation of the sample means. That's given to you with the formula sigma, the population standard deviation, divided by the square root of n. Or we can use the spreadsheet analytics in GeoGebra to give us that z-test of a mean directly or from the spreadsheet.